You can go.
Yeah. So again, hello everyone. Myself Deepak, and today we will gonna talk about macOS application penetration testing. So what does this exactly mean? This means thick client application testing. Like for Windows applications, you might have heard about some terminologies like thick client, fat client applications, thin client applications. So what are those exactly applications are, and how a pen tester what are the pen testers approach in order to do those testings, and what are the different vulnerabilities or what are the different misconfigurations which we can find while doing such type of testing. So for today's session, we will be looking at the macOS applications basically. And once again, I'm gonna start with my introduction. Myself Deepak. I go with my alias Monal. You can check out my YouTube channel where I post small walkthroughs of well-known machines or out-the-box machines or some couple of tips and tricks. You can also check out my Twitter profile. And I'm a cybersecurity enthusiast with uh, progressive 3+ years of experience. And I love technology. That's why I am a part of this cybersecurity field. And I love to work on web applications, identify logic-based attacks, especially logic-based attacks. Then I love to work on APIs, no matter if it is REST API, SOAP API, or else GraphQL, you can say. Then I go with mobile applications, network, thin client, which is today's topic. I'm also fond of AD, which was my previous topic. And I also love to perform cloud audits, mostly pen test and cloud audits, where I usually go with the black box approach. Instead of going ahead and getting the credentials, I go with black box approach. So yeah, uh, apart from that, let's start with our main topic, which is macOS application penetration testing. So what are the agendas for now? So as you can see, there are a couple of things which we will gonna discuss. Among them, here are the details, such as we will look at the application structure. I mean, when I say application structure, that time I mean that macOS application structure, like what are the things which are included in the macOS binary file, or is it actually called a binary file, or is there any other things which are available over there? That we will going to look at. Then we have this GUI testing, GUI testing. Then we will look a little bit about network testing, the different ways of network testing. We will look for a couple of techniques like how we can perform static analysis as well as dynamic analysis. Okay, so now again, as I was saying in the introduction part, that penetration testing is a vast field. There are a couple of things which we can do, like web, network, mobile, iOS, source code review, audits, and much more. And among them, there is one more part which is Pickline. What exactly is this Pickline application? It is nothing but a desktop application. Like if I want to take an example of Windows, then let's suppose that I want to access a browser, I want to surf a browser. Then we have a well-known pre-installed uh, browser, which is Microsoft Edge, which got replaced by Internet Explorer. And again, another example of Windows browser will be the Firefox, Safari, and all. So basically, the client applications are nothing but the desktop applications which we install in our respective operating systems, no matter whether they are Unix, I mean Linux-based operating systems, or whether they are the Mac or Windows. So a, a thick client can perform almost all the operations. It still needs to be connected to the primary server to download the program data and to update the operating system. Okay. What are the common types of common examples of the client as I was mentioning earlier on? There are some system browsers like Firefox, Google Chrome, and other stuff. And we also have this Sublime text editor, which serves as the purpose of the client only. We have Burpsuit, which is one of the pen testers' favorite in order to perform web application testing apart from Postman and other stuff. Then we also have a Zoom meeting, which currently we are using to take this session. Let's talk a little bit about the architecture of Bitcoin. So there are basically two different types of architectures. Those are the two-tier architecture as well as three-tier architecture. So what happens exactly in two-tier applications? So two-tier architecture is just like a client and server-based application where the client, I mean the desktop application, directly communicates with the server and nothing else. Or else it can be a server or it can be the database. So for example, like let's suppose I have a text editor which serves the purpose of which allows me to enter any detail. But I can't download any uh, file from using that notepad or using that text editor, or I can't update my text editor within the text editor. I mean, we get this option to update the application which are installed in the Windows, Linux, or Mac just by going to the menu and clicking on the update button. But if that update button is not there, then that means that the executable, not the executable, but the text editor is meant to communicate with the database only. So either the application is communicating with the database, as in to save any of the file, or either it is communicating with the server to download any of the file. So there should be only two entities involved in the architecture, application itself, or either the server or either the database. This type of architecture is known as two-tier architecture. Now again, the common examples for two-tier applications are the text editor, which I was saying earlier on, and the basic music player application, which doesn't have uh, internet connectivity. Because if there is internet connectivity, then it will gonna be shift from two-tier application category to three-tier application category. Because again, there will be the three entities involved: the application itself, the database. Because music, it is a music player, so the user must be required to save the music in his phone and then use the music player to play their songs. So if there is network, then it will be the three tier. But for this example, I have mentioned clearly as a basic music player, which means no internet is involved as of now. And then we have this three-tier application, which means there is a mediator, like the application server is there, and from the application server, the application can communicate to fetch the updates, and there is database which will be helpful to save the files into the local machine. Again, the common examples are browser. Browser is used to surf the internet. Browser is an application, that is one entity. Internet got involved, second entity, and with the help of browser, we can download any of the stuff from the internet and save it on a local machine, third entity. Same goes with the Burp Suite, because Burp Suite interestingly falls under three-tier category, because we can save the Burp Suite file in our own machine, as well as Burp Suite has this uh, what do you say, collaborator, as well as Burp Suite also has this option to check for updates. So again, internet got involved. So it is the three-tier application. Yeah. Approach to thickness. Uh, like each domain has their own architecture as well as the way it performs. Just a second. Yeah. Uh, each application has their own way to perform their work. The client applications are again of no exceptions. And the attack which involves on these thick client applications are most of the time similar to the web application attack as well as the system-based attack. Now, when I say system-based attack, that means that the specific vulnerability is going to affect your system, or it will going to affect your system via the application. Now, let's talk about the architecture of our macOS applications. So what do we get over here? So the macOS application is a software designed to run applications macOS operating system. Yes. Uh, we can't call the macOS application purely a binary file because it consists of several other files also. There are a couple of most popular macOS applications which are in the wild, which are known as Safari, Chrome, Microsoft Word, Excel, PowerPoint, and other stuff. So basically, we use couple of languages to create these applications, which are Swift, Objective-C. These two languages we can use to create this application. But also, macOS do support C and C++, which are again pretty old programming language, I would say, but still macOS has the support of C and C++. Now, many applications are obtained from the application store, but you, in the macOS, user also get this option to download and install the application from third party. So when I talk about the third party applications in Mac, there are little bit restrictions while installing the third party application. What are those? That we will gonna look ahead after a couple of minutes. So unlike Windows, where anyone can download any sort of information, unlike Mac, again, Mac, no, sorry, not Mac, unlike Linux also, Linux do support the third-party application installation because over there all we have to do is we have to use the package manager to download the applications, or else we can update the source list so that we can download and install the application pretty quickly. Or else we can use the deb file also to install it in the Linux. But for Mac, there are a couple of restrictions. Not talking much about restriction, I'll move forward with the architecture first. So after installing a specific application into a Mac, uh, there are specific locations on which my application will gonna get installed. Those locations are it will either gonna be in the slash application folder, or it will go either gonna be this users application path. Now these two things are pretty different. And for example, system applications are accessed through system slash applications path. And here are some of the path as well as what you can say the different types of applications which gets installed. So system applications are most of the time located under slash system slash applications. So if I wanna look at it, then let me show it to you real quick. Okay, I'm not near. Right. So I'm gonna go into this location and okay. As you can see, these are the system-based application which I got pre-installed with Mac, which are app stores, automator, calculator, calendar, chess, contacts, find my app, then launchpad, mails, and much more. These are the pre-default installed application which I got from Mac. So these are located under slash system slash application directory. Installed applications are usually installed in slash application or the other application followed by tilde. I mean, I'm not sure how to pronounce it, but I'm going to call it as tilde or tilde. So, install application, which means whatever application which we install in Mac. So let me show it to you, like what I am talking about. So over here, as you can see that I have this application name as a folder, and over here I can see all my application, which involves the install application as well as the system applications also, which are apps to Automator, books. These are the system applications and Cobalt Strike, Code Runner, Chromium, Clean My Mac, Cleanup also. These are my install applications. So basically this folder is nothing but it gives me the idea that these are the applications which are installed, and it merges all the system applications as well as the user install application, and it shows me all the results over here. But I am not sure what exactly is this. you can say. I'm not sure what path it is, like where it is located. So I'm gonna go over here, and once I press the option button, I get to see it is installed in macOS HD and application. So just a sec. Let's suppose I'm dragging it on my terminal. So as you can see, it is installed in slash system and in slash application. This book app is installed in this path. But at the same time, what if I drag my browser? This browser is installed in slash application instead of going ahead and getting installed or setting in the system location. It skipped the system and it is located in the application folder. Similarly, application data can be found in library application support for the application those who are running as root. And again for library application support followed by the tilde for this path is used for those applications which are running as normal user. We have some third-party daemons as well. So these daemons are nothing but you can call it as plugins for now. And these informations you can get under a library privilege helper tool if they are meant to run as root. Next up, we have this sandbox apps. We will look at what exactly is this sandbox again in a couple of minutes. So the sandbox applications are mapped and stored inside the container folder, and each folder has the folder name according to the application's bundle ID. Bundle ID as in, uh, if I am not wrong, many of the people who have worked on Android applications, over there we get the identifier name such as com.google.chrome. So the Google Chrome is denoted as com.google.chrome as an identifier. Similarly, for macOS, we get this bundle ID, and bundle ID is there for a couple of different applications which are serving their purpose as sandbox application. And again, similarly, Safari is known as com.apple.safari. Similarly, my Brave might be known as com.brave.browser. I'm not sure. There is a possibility. Next up, we have this kernel. So the kernel in Mac is located at System Library Kernels folder, and Mac's kernel supports some extensions as well, which are located in System Library Extensions, as well as third-party kernel extensions are also stored in library extensions. Okay, now macOS application can be distinguished by looking at the .app extension, because as you can see over here, most of the applications which I have ends up with the .app. But interestingly, as I was saying earlier on, that we can't say macOS application entirely as binary. Why? Because if I go ahead and if I check what exactly is this mail.app, so file mail.app, it is a directory. See, it is not entirely an executable, but it is a directory. So I can go ahead in this mail.app and again I can check what are the different things available over there, and I will be uh, shown some other files as well. So macOS application can be distinguished by looking for the app extension and are stored as package, also called as application bundle. So it is not a binary, it is known as application bundle. So whatever the directories whose names ends with .app, we can simply go ahead and call them as application bundle, which not only has the executable but other stuff as well. A bundle is a directory with a standardized hierarchical structure that typically contains the executable codes and the resources used by the code. See, usually a bundle appears as a single file in the finder, which is the single file over here, as you can see. It is actually a directory. Over here, it is a directory. To view the application's content, what we have to do, we have to right click on the file name and select show package content. Inside the content directory, you can find several subdirectories. Again, instead of me going ahead, cd into this app file and navigating all this content, we can do some other stuff as well, such as simply right clicking on this app, clicking on show package content, we will be provided with all the different folders and subfolders as well. And here is the resource, macOS, here is the library, then here are the frameworks which are used, code signatures, as well as some info.plist file. And my binary file will be located inside this macOS folder. This one is my binary. So if I wanted to verify it quickly, what I will do, I'll just quickly run the file, drag this executable, and you can see this is macOS 64-bit executable. So this is the binary file which if I go ahead and execute, my Brave browser will gonna start. See, and the rest of them are just the folders which are used by the application, not unnecessary folder. Those are very important folders because if I delete any of them, my browser might not gonna work properly. So this is the content. Again, over here, as you can see, there is an application which is known as dummy.app. Yes, for this demonstration purpose, I used Google and I took a couple of references from CyberArk and I was able to come up with the demo applications which I can show it to you guys. Okay, so over here you can see that there is a main folder which is content, and inside this content folder there are different files such as info.plist, macOS. Inside macOS there is my dummy executable. We have package info, resources. In resources we have other files, and in resources basically resources are the one which includes our code. Code as in exactly whatever we created the program, those codes will be available in this resources folder most of the time. And this signature will be available, application signature will be available in code signer. So what is this code signer basically is? So code signer is nothing but it gives me the idea whether the application has been verified by the Apple developer or authorized by the Apple or not, which we will again gonna look at this after time. Yeah. So now basic structure of macOS application bundles includes info.plist, macOS, resources and framework. Okay. So info.plist, what exactly is this info.plist? It is a configuration information for the application such as bundle identifier and bundle version. See, earlier on we were talking about this, correct? That sandbox applications are stored in library containers and each app has their own folder name according to the application's bundle ID. Similarly, this info.plist file also have the sorry, this info.plist file also have the bundle information, or you can say bundle identifier name of their respective applications. So, like suppose uh, over here we have this info.plist, and if I go ahead and if I open it in my VS Code, we will be provided with a lot of information. Let me zoom in. Yeah. So this is exactly how the info.plist file looks. This is nothing but an XML file, and there are a couple of interesting information, but we want to look at this. Just a sec. Let me search. Where is my bundle ID? Yeah. So as I was saying over here, with bundle information as well as bundle identifier. So the bundle version is available over here, and it serves as just the information and nothing else. We only get to see these versions. That's all. We can't do much about it. And then later on, we get this identifier, UT identifier. Okay, so this is my CF bundle identifier, which goes by com.brave.browser. So earlier on, I predicted it correctly. So my Safari is known as com.safari. dot browser something. Same similar go for the Brave, pom.brave dot browser. Now macOS. macOS contains the main executable file. Yeah. Resources. What exactly is this resources file? So resources file contains the application's resources such as images, localizations, and interface file. Long story short, we can say it has a different set of images which will be displayed inside the application as well as our own code. Some of the code, not entirely, and we have this framework folder. So framework folder, this contains frameworks and dynamic libraries loaded by the main executable. If we are using any third-party libraries, then it will be visible in this framework folder only. And this is exactly how a sample demo macOS application looks like. Let me quickly execute it. I mean, let me show it to you, like what it is. Explore how long it will gonna take. Okay, so we have a couple of applications, but I am more interested in the one which I created, which is Dummy. Let me open it quickly. And again, this code is not entirely made by me. I copy pasted the code from internet again. I did couple of modifications in the code, like using the WebKit or else getting the reverse shell directly from the application. These are some of the changes which I made, and the rest of the code I copy pasted it from Google, like executing the calculator and such. These are some of the things which I added over here, and rest are copy paste, to be very honest. And this is built in Swift language. As I was earlier talking about, that macOS application supports Swift, Objective-C, and some other legacy languages such as C and C++. Let me run my application so I can see this play button over here. Let me run it, build that app. Mhm. Okay, let's wait. Yeah. So over here, as we can see, this is my application. Let me minimize this. So let us first go ahead and see what are the different things which we can do in this application. So we see couple of not couple of we see one input field which says enter some text here. We get couple of buttons and we get this web page which is similar to example.com, which is loaded in an iframe. If a user first time sees this, they might wonder that whether it is actually loaded in the iframe or whether there are some other technologies used for Mac. So it is not an iframe. It is just that the macOS provide WebKit, which is used to execute the JavaScript. So I have used that. Let me show you the code also. So over here, uh, yeah. So over here, I have loaded this example.com, as you can see, example.com, and I have used this web view as well as I have used WebKit as well. Okay, so let me enter something like let's suppose hello Mushfiq. If I click on push, then I am provided with this cute little what you can say image as well as the same syntax got reflected back over here. Correct. What if I don't enter something and if I just simply go ahead and click on the push button, it says that please enter something. Apart from that, there is one website which is loaded over here. If I click on more information, I will be redirected to some other websites, and from there I can basically surf an internet. See, the PDF application PDF was also got rendered in this small section, but I can't go back. You see, Once I open any sort of file, I won't be able to go back and forth, but I do get this download button. Let's try to download this PDF. Are we able to download it? Mhm. Let me check. No, we are not able to download it. I mean, we can't download from here, but still we can see a lot of interesting information. And at the same time, there are a couple of more buttons which I added, such as Open Calculator and Surprise. So send and there is one more button which is send request. So if I click on this send request, what happens usually is that you can see that uh, application is trying to make HTTP request to localhost following the port 9999, which means that if a user goes ahead and click on the send request button, then there will be an HTTP request made to a particular IP address. So where is this port? Uh, Here it is. So I am sending a normal GET request to my localhost followed by the 999. Let me test it out real quick. So let me run my listener on my 999. Okay, okay, let's first try with listener. And if I click on this send request, you can see I got this GET request and user agent is nothing but dummy, CF network, and Darwin specifically indicates the Mac. If I keep clicking on the send request, I will get that request more and more. I think the HTTP server. Let's suppose I started a web server on my local machine, and then if I go ahead and click on the send request, you can see that the application keeps on making get request to my local machine. So this is one of the feature which I added. Later on, I added one more functionality, which is open calculator. Just by clicking on this button, I can open the calculator. As simple as that. I mean, for those who are much more fond of identifying RCE, they might get triggered over here. Like how just by clicking a simple button, the calculator is getting popped up. It's the thing that, I mean, over here I have simply stated the path of that calculator, and I have uh, specified this file URL with path, which means I have to open this path. So just by clicking on this calculator, I'm able to open calculator. Similarly, if I go ahead and change this path, I will be provided with some other applications, like suppose if I enter Safari, I will be able to open Safari by clicking this button. And the last but not the least, we have this surprise button. So let's see what exactly is this surprise button. So if I go ahead and click on this surprise, what happens? Nothing. The application is freezed. Application got freezed. So let me close my this connection and let me restart the app itself. Okay. And let me click on my surprise button. So over here, if you guys can see, I got a small message which says bin bash connection host is down and dev TCP IP address followed by port number host is down. So by looking at this syntax, it gives me a feeling that the application is trying to make some sort of connection to a particular host followed by port number 9001, meaning that the application is trying to send a bind shell to a particular host. So let's try to get reverse shell for the matter of time. Mine is 243.243 for, and now I'll have to replace my syntax. So why I am showing you this thing is because it is necessary to not just go ahead and blindly click on all the buttons. Okay. Sometimes there is a possibility that the application is built by a well-known hacker or some notorious hacker. And on the front, similarly to this, Like on the front over here, I get this button which says surprise, but on the back end, what it is doing, it is sending a bind shell to a particular system. In our scenario, it is me. So if I click on this surprise, as you can see, I got the reverse shell back. So this is, I am doing all this information, all this stuff on my local machine. Similarly, I can do it over the network, which means I can forward this shell to someone else, or I can forward this shell to someone listening in the speaker. So who am I? Again, Monal. But interestingly, this application says that surprise click for surprise. So the user might get confused or might get excited to see what exactly is this surprise. But little did he know that behind the scene there is a listener running which will going to get your shell and try to perform other types of attacks in your system. So let me close this quickly. Okay. So this is what exactly our application is. Now let's go back to our slides. Okay. Now application structure. Like we have couple of things to note it down. We have this application sandbox. So this sandbox is used to restrict the application from accessing system resource and user data. Then we have this capability and entitlements. These are the two mechanisms that determines what sort of permissions the application must have and what sort of user level access it should have. Capabilities define what the apps need to use like camera or the internet, whereas entitlement grants access and permission for the app to interact with the operating system and other apps. Like while developing the app, what developers can do, developers can, instead of going ahead and manually typing the code, they can in the Xcode navigate to the profile of the application. And in the signing capability over here, we can see this app sandbox category. And from there, they can enable a couple of things, whether applications should include incoming traffic, outgoing traffic, or whether applications should support any hardware support such as camera, audio, USB, and other stuff. What sort of access should that application have, such as contacts, locations, or calendar, and file tap access, such as user selected files, download files, as well as permissions. Read or write, they can change it to read only also and none also. Now coming back to our slide, what do we have next? Yeah. Now identify the like when we go ahead and when we talk about the GUI testing, there are a couple of things which we have to know, such as identifying the user input fields. So in our case, it is this one only. And after identifying the user input fields, we have to check for some well-known attacks such as SQL, XXC, command injection, XSS, and other stuff. Understand the application behavior and functionality, which we already did. Like by clicking on this send request, application is making a get request. We have this small little button to open a calculator, and we have this surprise, which is way dangerous because once I click on this surprise, I am unwillingly or willingly, you can say I am transferring my shell to someone else. Like, come on, have my shell and hack me. It's like I'm inviting hacker to hack me just by clicking on this surprise button. So let's do a small activity like let's try to execute a very basic XSS payload, which is uh, I will stick with script because it is pretty easy to read and understand. Script alert one, script. Let's see whether are we able to execute this XSS or will it gonna be displayed as it is. So no, it is displayed as it is only. That means there is a possibility that we can't do the XSS attack. And I am sure that we can't do the XSS attack on this application because I build it, not build it, I modified it and made a couple of changes. What about command injection? Let's suppose ID. Nope.
10 minutes left.
Who am I? Nope. Okay. So these are a couple of things which we can do with this application. Uh, Next up, what we have network testing, analyzing the network communication between the application and the server is important because By doing so, we will be able to understand what sort of things are going on behind the scene. Like over here, we got to know that the application is making a GET request as well as it is transferring my shell. And in order to perform macOS based application testing, it is mandatory to disable SIP. What is SIP? SIP is nothing but it is a system integrity protection. It is a security feature provided by the Mac. So long story short, if I have to sum this SIP mechanism, so it is nothing but you can call it as an MC for Windows. But over here we have the SIP. So SIP basically restricts a user to install any unnecessary third-party applications, and it also protects the user to not to modify any protected Windows folder. And this also applies for normal user as well as for root user because see, we those who use Linux or Mac or Windows, we all know that administrator except AD, okay, except AD, those who use normal Windows, normal Mac, normal Linux, we all know that admin or root access is the high command, okay. But Mac has this feature to restrict root user also to access certain set of files, and that is only possible because of SIP. So in order to perform this macOS based application testing, it is mandatory to disable this SIP. Okay, and SIP includes several mechanisms such as file system protections. Yes, I won't be able to modify certain set of files. Then it provides runtime protections as well. I mean, we won't be able to attach debugger over here. So when I talk about attaching a debugger, it means that I can use Frida tool again. Frida, most of the time we use for iOS as well as Android testing, but at the same time, I can use Frida for macOS testing as well. And with Frida, what I can do, I can attach a debugger into my application. So SIP will gonna prevent me, if enabled, SIP will gonna prevent me to do so. And it also provides some kernel extension protections as well. Let's quickly move forward. I'm gonna skip this part for now. How to disable SIP? So we can't directly go ahead with, again, if I'm logged in my machine and if I get this root terminal, still I won't be able to disable SIP because as I was saying earlier, as I said earlier, that root also has some sort of limitations. So in order to disable SIP, we have to go into recovery mode. We have to disable the SIP and then we are good to go. We can do anything. Now we have this network interception proxy, like we can use this Bubsu certificate. We can import or install the certificate in my own system and we can then intercept these, what you can say, the network traffics. And again, this Burp certificate will only gonna capture my HTTP or HTTPS traffic only most, and it will gonna ignore the TCP based traffic. So in order to intercept TCP traffic, we have one tool which is known as PTAP proxy. PETEP proxy. So let me this one. So what this application does is this application has the capability to intercept TCP as well as UDP based communication as well. Okay. So we can use this PTAP proxy in order to intercept TCP based communications, TCP based traffics, as well as we can use this burp suite to intercept HTTP based traffic. We can use Wireshark to get the details whether the traffics are going in clear text or not. There are a couple of other tools as well, such as Fiddler proxy, Charles proxy. We can use Proxyman, and Proxyman has this capability to attach the application, and then it will gonna monitor that application, like what sort of what you say, what sort of traffic it is making. Then we have this MITM proxy where I have to again target the specific application to intercept the request. We have this Postman. Now, there are a couple of things while doing the static analysis of an application, such as code signing. Okay, so we have this feature for Windows as well and for Mac as well. So what exactly is this code signing? Code signing is nothing but a signature as well as a name which will gonna give me the information that yes, a particular application has been signed by an XYZ entity, and that XYZ entity is verified by the Apple or notarized by the Apple. Okay. And how this code signing works. So basically it uses some digital signatures uh, with private key and public key. And once the application is signed with this private key and public key, the application, not application, but my Mac will gonna verify that application by using their own public key, whether this application is legitimate or not. There is one more thing to keep in mind, which is gatekeeper. Gatekeeper is nothing but a security technology that is designed to help to ensure that the trusted issue they might have you faced some couple of issues like
Yeah, you have 2 minutes.
okay, they have used couple of I mean they might have encountered that while executing the application they keeps getting one pop-up which says that macOS is not able to verify the developer. That is because of the gatekeeper. Okay. And yes, so how to identify whether the application is having any sort of signature certificate or not? That can be done by using a tool known as code sign, following the path of the application. By doing so, we can easily check for the what you can say, whether the application is signed correctly or not. So over here, as you can see that the signature is ad hoc, which means a proper, uh, it means that a proper certificate has not been installed. Then team identifier is also not set. Okay. So what exactly is this team identifier? It is a unique identifier code assigned to a team of developer upon registration in the application developers program, through which they will be going to be verified as a legitimate developer and they can build applications for different users. But this team identifier has bypass as well. Like a bypass is found in how third-party developers interpret the code signing API, which allows binary with ad hoc signature, just as this one, typically used for testing purposes, to appear as if Apple has signed it. So basically, there are a couple of attacks also, which was targeting this code signing feature. And a normal hacker can also pretend as a legitimate developer and makes you to install that application into the system. Then you will be prompted with that surprise button again. You will click that surprise button and you will be willingly going to give your access to that hacker. That can be possible just by with this code signing mechanism. Then we have this hardened runtime. So what exactly is this? This hardened runtime, it protects the runtime integrity of your software by preventing certain classes of exploits like code injection, DLL hijacking, as well as process memory space tampering. In Linux and Windows, we have this ASLR, address space layout randomization. The same is for Mac also, but the naming is different. It is known as process memory space tampering for Mac. And we have this entitlements. Entitlements are key value pair that grants executable permission to a service of technology, again, which we talked earlier on. And how to identify those entitlements, that can be done by using a tool known as JTool2 and providing the path location. So over here, as you can see, I'm able to get what are the different permissions which which are allowed for this application. So application has this sandbox permission, then application has this music read write, then application has this camera permissions again, file download read write, then what more, get task allow, network client and network server. So these are the permissions which we saw in the Xcode also, that these are the permissions allowed for the application. Same can be identified by JTool2.
Yeah,
Then we
you
have outdated
you need
libraries.
to finish it soon.
Yeah. So we have this outdated libraries like similarly to Windows-based applications, like while developing any sort of websites or any applications, uh, developers certain times uses third-party libraries, and it is quite a challenge to monitor those third-party libraries whether they are vulnerable or not. But for macOS application, we can do it very easily by using O tool. And over here, as we can see, it shows me the compatible version of a library which used for this application as well as the current version of this library. And similarly, it will gonna show me one simple prompt which says weak. It means that application third party, I mean the third party library used for this application is somewhat weak or might be exposed to certain vulnerabilities. That can be done. Then again, what are the different files created by application? Just like I said earlier on, that there are certain paths in the macOS where the application gets installed. The same can be identified by using activity monitor. What exactly is this activity monitor? This one activity monitor, which is similar to the task scheduler for Windows. So over there, what we can do, we can search for this application. Let's say mine is dummy. I can double click and I can check for the open files and ports. Like what are the different set of folders this application is trying to access. So these are the paths which my dummy application is trying to access. Can be easily viewable using activity monitor. And again, we can use Frida to check what sort of activity my application is using just by executing the app and using the Frida following by the script.js and its process ID. Now, what exactly is this script.js? Let me show it to you real quick. Is Frida scripts macOS in MacScript. So what exactly it is doing? It is checking that what are the what you can say, what are the things that application is trying to do. Open means that it is either accessing any files or it is actually making any sort of request to the network. That is denoted by this open. And we have this console.log, which means whatever application we're gonna do, we will be getting notified or displayed on my terminal by using Frida. And last but not the least, we can do some memory analysis with double LDB. Here, we can dump the memory and we can check whether some sensitive information is getting stored in the application or not. And for Electron also, we can, as I was saying earlier, that Swift, Objective-C languages are used. Similarly, we can use Electron, Node.js in order to create macOS application. And one can easily do uh, modification in Electron-based application just by extracting the app.asr file, doing the changes, and rebuilding it again, and we are good to go. So yeah, as of now, I would like to conclude over here. So I am now open for questions. So any questions do you guys have? Do let